clicker there as well.
All right, everyone hear me? All right, so I'm a deep sea microbiologist, but I used to be a mine waste microbiologist. So mining the deep sea has me coming and going. So how often do you think about the deep sea? Even to those of us who think about it all the time, it can seem as remote and as alien as space. Because after all, we know more about the surface of Mars than we do about the surface of the deep sea. And more people have been to space than to the bottom of the sea. But each and every one of us has a connection to the deep sea in our pockets right now, which are these. We're using more rechargeable batteries for phones, laptops, electric cars. And these have rare metals in them, like lithium, cobalt, and magnesium. But these are rare. There's only a few mines in the world that can produce these metals, but the demand is going up. So we're turning to the deep sea to try and bring in the shortfall. So there are companies developing this technology right now, and they're making these tough, impressive remote-operated robots that can go down and scrape off like the crust of the sea floor, or hoover up manganese nodules, or dig up the hydrothermal vents to get at the ores. And the idea is this waste rock is then piped up to a ship that sat miles or kilometers, depending, if you're on the sea surface. And then the waste rock and the treatment chemicals are then dropped back over the side, and they're dropped into a plume which enters the sea. And even though this sounds very technical, the basics are similar to mining on land. And see, this is where perhaps we ought to stop and think a minute, because mining on land creates a whole load of problems like noise, dust, release of heavy metals into the environment. And these problems persist for hundreds of years on land, and they're neither cheap nor easy to clean up. And the laws of chemistry and physics being universal, these problems are probably going to crop up in the deep sea mining as well. But because we know so very little about what's going on in the deep sea, this is a big problem, because we don't know how it's going to affect it. We don't know which parts of the deep sea have important endemic wildlife. We don't know which hydrothermal vents have a microbial community that might give us clues to life on Earth or even out in space. And these environments have been left undisturbed for thousands of years, so we really have no idea how they're going to react to being disturbed. And there's one of the few studies on the subject showed that after 35 years, a disturbed patch of seabed, there was no recovery. It looked exactly like it had when it was mined. So what can we do? Well, we have a couple of options. We can do nothing and say, yeah, it doesn't matter, we're never going to see it, it's so far removed from us, who cares? Or we can say, yeah, all right, it's having our phones and laptops and what have you, and mining the seafloor will be an inevitable consequence of our need for modern technology. And we would just say, okay, well, we'll just go to the less important parts. But how do you define less important? And who gets to choose? Who gets to make that decision? This approach would need an awful lot more research, legislation, and a ton of enforcement to actually work. And the third option is we can say, no, it's not worth it, we'll not go there. But in order for that to work, we've got to work really hard on reducing the amount of our demand. So we need to do way more on recycling electronics and making them last longer. But the thing is that this technology and this industry is starting up right now. The rules are being written literally. I think there was like 2 weeks back, there was a big thing about it. But yeah, so whatever you think, if you get your opinions known now, you might have a real impact on how this technology develops. Thank you.